Good morning, friends. Today we will be talking about recommendation systems and we will be discussing a particular algorithm that is implemented for automated recommendations called the Apriori algorithm. So, friends, recommendation is a really important part in daily life. So, we recommend things to people. For example, our parents recommend us the some items or clothes depending upon what they know about us and what they know about what we like. Our friends recommend us movies and other things based on our known tastes and other stuff. So basically these type of recommendations that occur in daily life are mostly based on the knowledge or personality of a person. In the same way, there are automated recommendation systems that have been developed taking this concept into account. For example, this is an email I recently got from Shoppers Drug Mart. It's a Canadian brand, and so what they do is, suppose I go to Shoppers Drug Mart, I buy some stuff, they have a record of my transactions. So what they do is they analyze the transactions, and from there they try to predict my shopping behavior and send the exclusive list of offers that are on the items they think I will like to buy. Similarly, this is another example of Netflix. Netflix is a movie channel kind of system. So Netflix, you might have seen if you watch Netflix, that Netflix recommends you movies and shows and other things. Now, what's the recommendation of Netflix based on? So it is definitely based on users' choice and preferences, and the preferences of users that Netflix think are similar to you. In the same way, when we buy products from Amazon, we also see a list of similar products or recommended products. So basically, there is a recommendation system that is at play, and these are examples of automated recommendation systems. Now, there is a concept called market basket analysis. Now, the market basket analysis means that if we can somehow analyze the purchase behavior of a consumer, we can actually make our sales better from that. So basically, the idea is that how can we use our understanding of the purchase behavior of a consumer to enhance the sales of a particular store or a firm. So essentially, market and basket analysis takes into account the buying preferences. Now, different kinds of groups have different buying preferences. For instance, if I am a family person, I would more likely to buy products that are used in the family. For example, kids' toys, diaper, bread, butter, and so on and so forth. On the other hand, if I'm a sports person, I would more likely buy products like water bottles, bottles, or some costume or other things, maybe running shoes. So the idea is, if we know the buying preferences of different groups of people, it is more likely that we can recommend products to that group. Now, there are other buying patterns, for example. So, young people buy something, old people like to buy other stuff, and all. So, can we actually understand the baskets of shoppers and try to find out the relationship between the items? That's the whole idea of today's presentation. And then, can we develop an automated algorithm here? So now, why market basket analysis? It's a really good question to ask. Why should I do that? I gave you a few clues that we want to understand the behavior of the consumers and then try to recommend products based on that. But the first thing that market basket analysis can do for us is that it can explore the hidden buying patterns. For instance, if somebody buys bread, it is really likely he or she can buy milk. If somebody buys laptop, it's obvious. Like, you don't need an automated algorithm to predict that there is a high chance that the person will buy a laptop bag. But there might be some other hidden buying patterns which are not so obvious in common sense. For instance, if somebody is buying bread, he may like to buy tea bags, or if somebody is buying a laptop bag, he or she is buying milk. So there are hidden buying patterns that can only be unearthed if we do the market basket analysis. Similarly, item aisle arrangement. What this means is, suppose if we know the relationship between the items, suppose we know that bread and butter are frequently bought together, then we can put those two things together in similar aisles so that it enhances users experience, and users have or consumers have no difficulty picking these items together. Similarly, promotional discounts can be applied only on one of the pair or multiplets of items. Suppose if we just put a promotional discount on bread, the person, because bread is associated with milk, we don't need to put another discount on milk. So the promotion and discount should be enough to uh, get the user motivated to buy milk also. In the same way, the advertisements can be tuned in the way that the products can be advertised together, and similarly, new products uh, can be uh, can be designed based on market basket analysis. For example, uh, a new product can come that has laptop bag and laptop together, or some pairs of products can be advertised as new products. So there are many advantages of doing market basket analysis. That's clear from this conversation. Now let's move forward. Now, what are basket transactions? Basket transactions, you might have understood by now. A basket transaction means a transaction that contains the items in the basket of one consumer or user. So suppose you get all the basket transactions, all the information of all the transactions that are done in a store over a period of time, and you analyze them. And can you analyze the behavior of how the items are grouped, are bought together by different users? So this is an example over here. It's an example of a transaction of local at a local market. So there are five baskets shown in the picture, which indicates there'll be five transactions, and each of these transactions have different kinds of items. Some items are common, some are not. Suppose T1, in the first transaction in the first basket, there are items A, B, and C. But in the fifth transaction T5, we have B, C, and E items. So we can look at it in a little bit of more detail from here. So if we look at this, so suppose you have a transaction that's shown on the right side. So large eggs, milk, cottage cheese, and everything. So you may have thousands or millions of such transactions. We can number each of those transactions if we want to get the data in a particular format. So over here, it's a very simplified, simplistic example of just 20 transactions brought out from 20 baskets. So these are essentially the baskets, so that I can just denote the transactions by the transaction numbers, and each of the transaction number has a basket which has different kinds of items. As I said, it's a simplistic model, so we are only accounting for almost nine items over here: apples, beer, cheese, dates, eggs, fish, glue, honey, and ice cream. So this is, of course, a really, really easy example to follow, and one can actually extrapolate all the um, all the principles from here. Now these are the items. Now there are three things: transactions, items, and baskets. We're not going to discuss the baskets anymore further because transactions and baskets mean the same thing. But the idea is to show you how the data, where the data comes from. You have transaction receipts, and the data from each receipt is stored, and that can be put together in a format like this. Now we have to, the idea of this presentation is to understand how to uncover the item association rules. Suppose if I buy A, what's the chance that I will buy D? Or suppose if I buy B and items B and C, what's the chance that I will buy A. For example, if I buy apples and oranges, what's the chance I will also buy bananas, and so on and so forth. I am giving examples of closely related items over here, but the whole idea of this market basket analysis is to uncover hidden associations. We should keep that in mind. Now, how we derive the association rules? Now, association rules are derived in an if and then format. If I buy item A, what's the chance that I will buy item B? And then if we find out that value of chance or likelihood, we can arrange the association rules based on that, and then we can start recommending items. Okay, so now the first part, which is the if condition, is called the antecedent, and what's the result of that, that's called consequent. Suppose if I buy A, that's an antecedent, and B is a consequent of this. So this is a terminology of association rules that has to be kept into mind. Now, what I'm showing over here are single cardinality associations. What this means is I'm just associating one product with another product. You can also have pairs of products A and C associating with B, or you can have pairs of products associating with pairs of products. For example, A and C associating with B and D, and so on and so forth. So the rule does not restrict you. Actually, you can have whatever the magnitude of antecedent, the number of items in antecedent or consequent here. Now, this is a statement of the a priori algorithm, which we will be implementing, trying to understand using a simple example and then implement it on a particular data set. Now, this a priori algorithm, it uses frequent item sets. That's the first thing. See, if we are trying to derive association rules between two items, the items should be frequently brought together. If the item is an infrequent item that's not really liked by users or consumers, it makes no sense from a business perspective to, you know, kind of try spend time deriving the rules. So that's why we take into account frequent item sets, and it is based on the concept that a subset of a frequent item set must also be a frequent item set. This is a really important concept. You may not understand this second sentence right now, but when we try to show you how it works with an example, I think it will be clearer. So let's leave it for the time being, but keep in mind that we are going to take only the frequent item sets to generate association rules. Now, let's start with a simple example again. So we have data of 5 baskets of 5 transactions, and each of these transactions contain up to 4 items. So what you can do is, what's the first step in a priori algorithm? In the first step of the a priori algorithm, we need to make sure that we are only taking frequently bought items. Now what you can do is you can count the frequency of items. Now you can check in the first table, the item 1 comes in transaction 1, transaction 3, and transaction 5. This means it's coming only thrice. Similarly, item 2 is coming in transaction 2, T3, and T4. So it has a what you call as a support of 3 or a frequency of 3. And but what you will notice is item 4 is coming only once. So now at this point, what you can do is you can put a cutoff for the values of for the frequency values, and then you can discard the items which are not really frequent. Essentially, in the 5 transaction data set, item 1 is occurring 60% of the times because it is occurring 3, and 3 divided by total 5, if you get the percentage out of it, it's going to be 60%. Now here what I have done is I have applied the cutoff of 40% over here, that the item should be occurring in 40% of the transactions. And what I can do is I can discard all the items that are not really frequent. So the word support here is actually not used in the real technical sense over here. It is basically a frequency and not a support. In real technical sense, if you want to calculate support, you have to divide this frequency by the total number of occurrences. So essentially, if you want to calculate the support for item 1, you have to divide 3 by the total. 3 plus 3 plus 4 plus 1 plus 4, you will be able to get the value of support. But like this support and frequency mean the same thing right now. I don't want to confuse you, so let's keep these values, which are very simple, over here. Now the idea is, now I applied a filter, I applied a cutoff of that at least my support or my frequency should be 40%. Doing that, my item number 4 is discarded. Now I have the filtered data set over here. Now I will take this item set forward and make pairs of items from this filtered one, or what you call is pruning. This process is actually called pruning. Pruning means we are cutting off the stuff that's not really frequent. Okay, so now let's take this F1 into the next slide. And as I said, these are one item sets we were discussing. Now we will be making paired item sets over here. So let's look at this F1 which I brought from the previous slide. Now I will create the two item sets from here. The transaction table is given at the top left of the slide for your ready reference, because we need to count the frequencies again. Now this is a two item set. Now what kind of supersets you can build up, two item supersets you can build up from these one item sets? So it is obvious, put all the combinations here, 1 2 1 3 1 5 2 3 2 5 3 5, and now you can have to calculate the support. Now for calculating the frequency of our support, you have to use the transaction table that's on the top left of this slide. So let's see, when in how many transactions items 1 and 2 are brought together. It only occurs in transaction 3. That's a single transaction, so we'll put the value of support as 1. Then we can calculate 1 3. When are 1 and 3 brought together? It occurs in T1, T3 and T5, so that's why it has a support of 3. And in the same way, we can calculate the frequencies of each of these items, and then we will do the pruning. Because we have a support cutoff of 40%, the value of this support should at least be 2 over here. That's why we have filtered this data set, and you come up with only these many items, these many two item sets over here. Now we can move further. You might have guessed from here, now we have to create the three item sets from the two item sets. Now from two item sets, we can generate the three item sets further. Now, how will generate the three item sets? Take the two item sets and make combinations from there. So the combinations will be 1 2 3, 1 2 5, 1 3 5, and 2 3 5. And now we need to calculate the support values of each of these. Now 1 2 3 occur together in transaction number 3, so they occur only once. 1 2 and 5 also occur only once, and that's in transaction number 3. 1 3 and 5, they occur twice in transaction 3 and transaction 5. Similarly, 2 3 and 5 occur together in T2 and T3. So 1 2 3 has a support value of 1, 1 2 5 has a support value of 1, 1 3 5 has a support value of 2, and 2 3 5 has a support value of 2. Now by this we can see that we can discard 1 2 3 and 1 2 5 sets, and keep 1 3 5 and 2 3 5 because they are above the minimum support value. But we have to use a priori algorithm, the statement over here, which the second statement of which says that a subset of the frequent item set must also be frequent item set. So which means we need to check the subsets of each of these sets and also check their frequencies and find out whether they are above the minimum support value. Now let's check the subsets. So for example, this 1 2 3 has subsets of 1 2 3, 1 2, 1 3 and 2 3. We have to check the frequencies of each of these subsets, and we can use the table on the left side to check the frequencies of paired subsets. And what we find is 1 and 2, 1 2 set is not there because it's below the support cutoff, so we need to discard the whole set because one of its subset is below the support cutoff. But we can keep the 135 superset because all of its subsets have a reasonable support value. So that's the whole idea of a priori algorithm. So if we have larger supersets there, we need to check the frequency or the support of the subsets also, as well as the support of the superset, to kind of recommend them further. Otherwise we will just discard the supersets which have any of the subsets that fall below the support cutoff. Now we can see these two of them were above the support cutoff, and all of their subsets have a reasonable support. 1 2 3 and 1 to 5, the above two, they did not have their own reasonable support, and one of their subsets also do not have a reasonable support. So well, we could have discarded 1 2 3 and 1 to 5 just based on the fact that they did not fall above the support cutoff. But for the illustration purpose, we also checked their subsets. In practice, if we work with larger data sets, it is possible that you may encounter supersets which have a reasonable support, but maybe one or two of their subsets may not have a reasonable support. So we have to discard those supersets based on that. So in this particular case, we have to move forward with only two supersets or three item sets. That's 135 and 235. And this slide actually perfectly explains or illustrates the concept of how we check the subsets of a frequent item set and see their frequencies. Now we can build the four item sets over here because we have up to four items in each transaction. The only four item set we can make is 1 2 3 5, and that occurs only in one transaction, which means it does not have a reasonable support. And if it does not have a reasonable support, we have to discard it or prune it, which indicates that we will be keeping only one item, only up to three item sets. Now once we have the three item sets, the biggest superset that we have got, we can frame the association rules over here. So take the superset, and what you should do is look at its all possible subsets. Now all possible subsets of 135 are 1315, 35, and 135. Now you may notice that we did not write the single item subsets in the previous slide. There is a reason for that, because 1 3 and 5 were already frequent. We had already pruned the infrequent single item sets, so that's why we didn't have to write them again. We just checked the frequency of two item subsets there. But over here, while framing the association rules, we have to bring on all the subsets, whether they're two item subsets or one item subsets. Once we have brought them, what we can do is we have to, now this is important, we have to frame the association rules. So the way we do it is, for every subset S of I, so S is a subset and I is a superset. Suppose 135 is S and all these subsets are 135 is I and all these subsets are S. So we frame the statement that S recommends I minus S if the support of I divided by support of S is greater than a threshold value or a minimum confidence value. Now what this means is, uh, suppose I have this item S which has some frequency, and then your whole item set I which has some frequency. So the idea is that the two items should be the two items which we are combining, or three items we are combining, should be bought together in a reasonable number of transactions. So support of S means over here is what's the total number of transactions in which S occurs. The support of I means is what's the total number of transactions in which S occurs with other items. Now the ratio of the total number of transactions in which S occurs with other items to the total number of transactions in which S occurs irrespective of whether other items are there or not should have a minimum value, which means S is bought in many transactions together with other items. Only then it makes sense to frame the association rules. So this is defined by something called confidence value. The confidence value is a ratio of support of I to support of S, which essentially indicates that there is a reasonable kind of we have to put a cutoff that the item S is associating with other items in the set. So in this case, suppose we put a 60% cutoff or a zero point 0.6 cutoff, which means in 60% of the transactions it is associating. So we can take it and move forward from here. Now this is a general statement of the rules. Now we will apply this rule for each of these subsets and supersets and frame association rules. So start applying now. Let's take our first superset, that's 1, 3 and 5. So let's make the first rule, that is 1, 3 associates with 1, 3, 5 minus 1, 3, which means as S associates with I minus S, which means if items 1 and 3 are bought together, what's a likely chance that item 5 will also be bought with 1 and 3? So now we have to calculate the confidence, which is support of 135 divided by support of 1, 3. So you had the transaction table earlier. One can look at the support values, and the value comes out to be 66%, which is above the confidence cutoff of 60%. This means this rule will be selected. In the same way, one can move forward to the rule 2. Now you are checking the next item subset, which is 1 to 5. Again, uh, S2I minus S, which means if I buy I 1 and 5 together, what's the likely chance that 3 will also be bought? We will calculate the confidence value and check if it is above the confidence cutoff. Now same way for the next subset, and we will keep doing it, and we will until find that rule 5 and 6 do not have a reasonable support confidence here. The value of confidence is 50%, which is below the cutoff. We will reject these rules. Now this is a general idea of framing rules. You take the superset and apply this concept, and then put the confidence values over there and keep finding out the rules of associations between items. Now one can extrapolate it to a larger data set. So we are generalizing a concept. We had a five transaction data set. Let's generalize it. So first thing you need to do is you need to think of the minimum values of support and confidence that you want to put there. So the meaning is like you need to have a frequency cutoff, you need to have a frequency of association cutoff there. Once you have those values, you need to extract all the subsets having higher values of support, which means you will keep on pruning the sets that do not meet the support criteria. Then you select all the rules from subsets which have confidence value higher than the minimum threshold. That's what we were doing in previous slide. But the next thing is important. We have to order the rules by the descending order of lift. Now, lift is another parameter. Now, support, you understood. Support is the frequency of the transaction. Support signifies the frequency of the transaction, or you can, if you want to define it in the technical sense, support means the fraction of total transaction in which a particular item or item set occurs. Now, the confidence is the fraction of the transactions in which the item associated divided by the total number of transactions in which the item was present, whether it associated or not. And the third thing is lift. Now lift is another parameter. Lift actually signifies how much the sales of the item A were lifted when it was bought in association with other items. Now we will frame association rules only when we see that the association between the items is leading to some advantage or profit. So lift is a parameter which tells you how much lift occurred for the purchase of item B, for example, when it associated with A. Now then that's why you order these rules by the descending order of the lift values. The greater the lift value, the greater is the chance that the item association led to a higher purchase value. So generally, if you have a lift of 1, this means it does not matter whether, uh, which means no extra support is provided by association. If you have a lift of value of less than 1, that means that if the association is negatively affecting the purchase of some particular item. And if you have a higher than 1 value, this means there is an extra, you know, probability of purchasing that occurs because of the association. Generally, a lift of 3 is considered as a good parameter. But what we are going to do is we can arrange the rules in descending order of lift over here. Now, once we can do that, the association rules will come up. Now let's apply this concept to a particular data set over here to kind of see how we do it in Python. I haven't actually taken over here a real transaction data set to just change our mind and see how the same concept can be applied in a variety of different circumstances. I have taken a data set, and what we will try to do is we will try to find the association between two movies. Which means if somebody is watching movie 1, can we recommend the movie number 2 to that person, based on the association rules or based on the strength of association rules? Because essentially the whole idea of this a priori algorithm is to recommend the things. If we have the associations figured out, if we have the association rules figured out, suppose a person is buying item 1 and 3, and the 1 and 3 associate strongly with item 5, we can recommend item 5 to the person, or we can put that in the same aisle, or we can provide discounts, or whatever I told in the previous slides. In the same way, in the movies data set, what we can do is, if somebody is watching a particular movie and that movie strongly associates with some other movie or some other two movies according to the association rule, we can recommend that movie to the person. Now let's see. So this is a movies dataset which I downloaded from in it is in a CSV comma separated values format, and it's downloaded from the link here. You can go ahead and download this dataset. And so once we load it in the Python, so we use pandas to load the CSV inside. Don't keep the headers, and then you can see the first 5 lines of the data. You can see a lot of these are nan values, and uh, you can't associate these, you can't keep these nan values, they don't mean anything over there. So essentially what you can do is you can go ahead and take this movies data set, and then you try to frame the association rules. So essentially what it is, it's a bunch of 7,501 different transactions of movies, I would say. So in the row 0, you have 20 movies essentially, and in row 1 you have some movies, some are nan values over there. Essentially you have a total matrix of 7501 cross 20. So you can think of it as 7501 transactions and 20 items, and that's the way we are going to move forward over here. So it's a 20 items data set, but it has lot more transactions than what we were seeing earlier. So one of the thing is we have to remove the nan values, because they are not real movie names. Nan means not any number or not a number. So essentially we need to get rid of them. The second thing we need to do is we need to change the format of this dataset so that the a priori algorithm implemented in Python can read it easily. And the format that a priori algorithm can read is a list of lists. So let's go ahead and create a list of lists, and then take only the non-nan values into those lists. So what we can do is we will initialize a movies list, and in the movies list we will put the each line, each row of the data set, and the movies will be the total data set. So you will have uh, 7501 entries in the total movies list, and each of the list will have a list of up to 20 items. So I initialize the movies list, and we start putting a loop here, starting from 0 to total first item of the shape of the data set, which is 7501. So the range of this will be 7501. As I said, we will have 7501 transactions of movies, and then we initialize inside this, we initialize a movie list which will have up to 20 values. That's a second item of the shape, which is 20. And then what we say is, if any of those items is a nan, is a not nan, we will take it. If it is a nan, we won't take it, and then we will start appending them into the movies frame, and then finally we will append each of the movie into the movies list, and finally we will have a list of lists like this. So once we have that, then we have to initiate the a priori algorithm. For that, as I told you earlier, we need to set up uh, support, confidence, and lift also. So for the support, we want only movies that are purchased at least 40 times. So there are 7501 transactions, and then we want at least 40 times. So what we can do is we can get a fraction over here, because the program accepts fraction, not the real frequency value. So you divide 40 by 7501, get whatever the number it is, and put it in the program. In the similar way, we need to have a minimum confidence of 20%, which translates to a fraction of 0.02. You put that value and the lift of 3. That's what we are going to do over here. So minimum support is 40 divided by 7501, minimum confidence is 0.2, and minimum lift is 3. It's really simple. Everything is already coded in Python. Just use a priori algorithm, give your transaction data, which is a list of lists, and then it will give you the association rules. It's so simple. Whatever we have discussed in the algorithm earlier, that's already implemented. We were doing that exercise for understanding how it is done by Python. You can look at the association rule. It built up 19 association rules for us. And so, for example, this is Red Sparrow and Green Lantern, two movies. They are within the support of 0.0057. You can actually look at other stuff. There is a confidence value of 30%. You have a lift of 3.7, and in the same way the things are arranged. I have just shown you the first item over there. Now you can create a data frame from here. So what you need is title of the first movie, title of the second movie that is associating, because we are only choosing pairwise associations over here. And then you can, and that's the default actually in the association rules. You need to change how many associations you want probably. And then you can uh, initialize a title 1 movie list, title 2 movie list, support list, confidence list, and lift list, and then keep appending stuff from each of these 19 things, 19 association rules, which they have shown. And this will come out to be a data frame like this, which is easy to understand. Now if somebody has taken Red Sparrow, it is likely that you will end up recommending Green Lantern, because it has reasonable support, confidence, and lift values. So this is just for an illustration purpose, but in a real data set there are more tighter values of support, confidence, and lift, so that some reasonable profitable kind of associations are being worked out. But I think it's a fairly good example to understand the algorithm and see how it is implemented in Python. And I hope you learned something new from here, and drop me comments if you need any clarification to any of the things I have discussed here. And thank you very much.